Hello, teacher. So, my name is Leon Justin Hong, and my group member is Wang Xinya, and we are from Section 3, Group 5. So, today our group will talk about the data mining group project that are based on the accidental drug-related dataset. In our presentation, I'll first explain the report part, including the project background, objectives, pre-processing, the methods we use, and the main findings. After that, my teammate will demonstrate the Python code and briefly explain how the models were implemented. So, firstly is the background of the project. Our project is based on the accidental drug-related deaths dataset provided from the SMO1. This dataset contains a case-level information such as age, sex, race, and drug involvement of the indicators. We selected this dataset is because it is suitable for multiple data mining tasks. It contains both numerical variables and categorical variables, and it also includes several drug-related attributes that are useful for prediction, clustering, and anomaly detection. And then next is the problem statement, which there are four problems. The first one is, can we classify the death cases that involves in the fentanyl? And secondly, can similar cases be grouped into a cluster based on the drug-related variables and demographic? Third, we predict the age of the victim based on the case attributes? And fourth is the can rare cases be detected using the anomaly detection techniques? Next is the data preprocessing. The objectives of our project were quite clear. So, um, firstly, we wanted to pre-process the dataset properly using the suitable cleaning and transformation methods. And then, secondly, we wanted to apply for data mining techniques that uses Google Colab. Third, we wanted to evaluate the models using an appropriate metrics. And finally, we wanted to visualize the results and interpreted the findings in a meaningful way. And then next is the data processing. Before applying any models, we first prepared the data. So to simplify the analysis, we selected only 7 columns from the original dataset. They are age, sex, race, heroin, cocaine, fentanyl, and any opioid. We chose these variables because they contain both demographic information and drug-related information, which are relevant to all our four mining tasks. Next, we handled the missing values that are handled before with the median. For sex and race, which are categorical variables, we replace the missing values with unknown. And then after that, we transferred the drug-related uh, columns into binary values. So if the value that started with the I, it will be converted into 1. Otherwise, including the missing values, we converted into 0. And then finally, we encoded the categorical variable sex race into numerical values using the label encoder. This was necessary because machine learning algorithms usually required a numerical input rather than text labels. Next is the implementation of the techniques. So firstly is the classification, next is the predictive analysis, and then next is the clustering, and lastly is the anomaly detection. So firstly, I'm going to talk about the classification. So the classification, we use the logistic regression to predict whether a case involved in fentanyl, which the target variables was the binary fentanyl column, and the remaining selected variables were used as predictors. We split the dataset into training, testing, and testing sets are using an 80 to 20 ratio. We choose logistic regression because it is simple, suitable for binary classification, and easy to interpret. Next is the predictive analysis. For the predictive analysis, we use the linear regression to predict the age of the victim, which in this case the age and the dependent variable and the other selected variables were used as a predictors. We also use the same as classification, which is 80 to 20 trains test split. We choose linear regression because it is one of the most basic methods for predicting the continuous values. Next is the clustering, which for the clustering we use the k-means for cluster. Before the clustering we use the standardized the feature using the standard scalar, uh, which it's because the k-means is distance based on um, and requires the variables to be on a similar scale. For simplicity, we set the number of clusters set into just 3. We selected the k-means because it is so common and easy to understand for the clustering algorithm. Lastly is the anomaly detection. For the anomaly detection, we use an isolation forest, which this method is suitable because does not need labeled anomaly examples, as we set the contamination parameter to 0.03 in here, meaning that about 3% is to be anomalous. And then next is the evaluation and the validation of models. To evaluate the classification model, we use accuracy, precision, recall, F1 score, and five-fold cross-validation. The logistic regression model achieved an accuracy of 0.7935, which the precision is valid on the 0.8147, and the recall is 0.8894. And the lastly is the F1 score, which is 0.8504. And the cross validation score was 0.8509. This result shows that the classification model performed well, especially in the identifying in the fentanyl-related cases, and it was relatively stable. Next is for the predictive evaluation. The evaluation is done by the MAE, RMSE, and the R-square. The linear regression model is 0.2 achieved on an MIA of 10.6, an RMSE of 12.49, and an R squared of 0.0289. This indicated a weak predictive performance that meaning the selected variables could not explain each variable. For the clustering, we used the silhouette um, score Davis building index and the Kalinsky-Harabas index, which the resulted were 0.2606, 1.6133, and 2.2636, respectively. This suggests that the data had some cluster structure, but the separation between the clusters was only moderate. For the anomaly detection evaluation, the isolation forest model identified 359 anomalous cases and 11,622 normal cases. Because there were no labeled anomaly examples, we mainly evaluated the model based on the number and characteristic of the detected outliers. Next is the anomaly detection and visualization and the interpretation. For the classification, we use a confusion matrix. This supported the model's good recall and showed that if it is correctly identified many fentanyl-related cases. For the predictive analysis, we use a scatter plot of an actual age versus the predicted age. Many points were far from the reference line, which supports the weak regression performance. For the clustering, we use a PCA-based scatter plot, and it showed some grouping patterns, but the clusters still overlap, which matches the modern clustering evaluation results. And lastly, for the anomaly detection, we visualized the anomalies as a small subset of unusual records that suggested that the model was able to capture rare or atypical patterns in the dataset. So lastly, in conclusion, our project successfully applied 4 data mining techniques to the accidental drug-related deaths dataset. Among the 4 tasks, the classification model performed the best. It achieved the good accuracy, strong recall, and stable validation results, showing that the selected variables were reasonably effective for identifying the veterinary-related cases. Uh, then, the predictive model was much weaker, which means that the selected features were not enough to explain the age well. The clustering model found some meaningful grouping patterns, although the clusters were not strongly separated. The anomaly detection model identified a small set of unusual cases which may be useful for further investigation. In terms of the limitations, we only used a small subset of the original variables, and we did not perform advanced features engineering or extensive model tuning. Also, the anomaly detection results could not be directly validated because there were no labeled anomaly cases. For the future work, we could include more variables from the original dataset, compare more algorithms, and improve the preprocessing and visualization steps for the deeper analysis. So next, my teammate Wan Xinyang will explain the code of the demo.
Hello teacher, now I will continue with the code demonstration part of our project. I will explain the Python workflow step by step. First, we import the required Python libraries. Here you can see it. We used pandas for data handling and numpy for numerical operations. From scikit-learn, we import the tools of preprocessing, model training, clustering, anomaly detection, and evaluation. For example, train test split was used to divide the dataset into train and testing sets. Label encoder and standard scaler were used in preprocessing. And then we import the forming methods: logistic regression, linear regression, k-means, and a solution forest. We also imported different evaluation metrics for each task. Next, we loaded the dataset using pd.read SSV and displayed the first 5 rows with df.head. This step helped us inspect the original dataset structure. From the output, we could see that the dataset contained many columns, including demographic information, location-related information, and drug-related attributes. Since the original dataset was quite large and complex, we decided not to use all columns directly. Instead, we select a smaller set of relevant variables for our analysis. And then we selected the chosen columns. In this step, we kept only 7 columns: age, sex, race, and so on. There's 7. We selected these columns because they include both demographic information and drug-related indicators. This smaller feature set was easier to pre-process and still suitable for our 4 data mining tasks in our project: classification, predictive analysis, clustering, and anomaly detection. And after selecting the columns, we handled missing values. For each, which is the numerical variable, we replaced the missing values with the median. We use the median because it's a simple and robust way to fill missing numeric values. For sexy and race, which are categorical variables, we replace the missing values with unknown. This step was important because machine learning models generally cannot handle missing values directly. And next, we transformed the drug-related columns into binary values. The original values were not fully numerical, so we converted them into 1 and 0. If a value started with Y, we changed it to 1, which means the drug was present. Otherwise, including missing values, we change it to 0, meaning the drug was absent. We apply this transformation to like fentanyl or any opium and so on. After that, we encoded the categorical text columns, sex and race, using label encoder. This step converted text labels into numerical values. It was necessary because most machine learning models in scikit-learn required numerical input rather than strings. After this step, the clean dataset was ready for modeling. And the first modeling task was classification. Here we used logical regression to predict whether a case involved fentanyl. So in this case, fentanyl was the target variable, and the remaining selected variables were used as input features. We split the dataset into training and testing sets using an 80-20 ratio. Then we trained the logistic regression model and generated predictions on the test set. To evaluate the model, we used the accuracy, precision, recall, and FE score. We also used 5-fold cross validation to check whether the model was stable across different splits of the data. These results show that the classification model performed well, especially in identifying fentanyl-related cases. Also, the cross-validation result was very close to the test result, which suggests that the model was relatively stable. The second predictive analysis. The second task was predictive analysis. Here we used linear regression to predict age. In this model, age was the dependent variable, and other selected variables were used as predictors. Again, we used an 80-20 train test split. After training the model, we evaluated using MAE, RMSE, and R-squared. From the output, the model produced like this. Like here, you can see the result. These results show that the predictive model was quite weak. The low R-square means that the selected variables could not explain age very well. So compared with the classification task, this model had much lower performance. And the third task was clustering. For this part, we used k-means clustering before applying k-means. We first used the standard scalar to standardize the dataset. This step was necessary because k-means is based on this distance, and features with larger numeric ranges can dominate the clustering result if they are not scored properly. After standardization, we apply k-means with 3 clusters. Here you can see. This value suggests that the dataset has some cluster structure, but the separation between clusters was only moderate. So the clustering result was useful for exploring exploratory analysis, but the groups were not very strongly separated. And the final task was anomaly detection. For this part, we used isolation forest. This method is suitable for unsupervised anomaly detection because it does not require labeled anomaly examples. We set the contamination value to 0.03, which means the model expects around 3% of the cases to be unusual. After fitting the model, each record was labeled either as normal or anomalous. And here's the output you can see. These anomalies may represent unusual or rare combinations of demographic and drug-related features. Since we didn't have labeled anomaly data, this part was mainly used for exploratory analysis rather than strict supervised validation.